Hello, my name is Lincoln, and I'm going to start off today with a bit of an introduction to C and C++, and then go into pointers in particular, because pointers are one thing that is sort of unique to C, and a lot of people get tripped up when they start trying to learn pointers. So what I've got open here is a C++ script that I just wrote really quickly today, and it's going to cover a couple of the main introductory things that you need to know for C++. So at the top we got two lines here that say include, and then they've got two different second parts after them. So the first difference are these carets or angled brackets, some people call them. These mean that what's inside of the brackets is a C++ common library. So a C++ common library is something that's default in C++. It comes with C++, you don't have to write it yourself. And basically it contains a list of functions and things that you can use as part of your program that you don't need to write yourself because they've already been done for you. And then the second one with these quotation marks, this is the name of a file that I wrote myself called printer.h, and in fact you can see right here in this second tab I have printer.h open. So the first thing to note is the .h ending stands for header. So this is a header file, and specifically it's a C++ header file. So you should be naming all of your header files with this .h at the end. Now, I will skip over what a header file is for the moment and come back to that later because there's some things I need to explain first. So you may have already started reading this in green. This is a comment, and this is done with two forward slashes at the start of a line. So this means that the computer will not read anything after these two forward slashes. It will ignore everything on this line. So everything has been highlighted in green automatically to, make it really obvious that all of this is not being included or not being read by the computer. So it's marked as a comment, really obvious by changing the color. So basically what I've written here is an explanation of the main function. So firstly, a function in C++, which should be pretty much the same with all programming languages, is basically a set of instructions that you can run lots of times. You can just type one command, the name of the function, more or less, to run everything inside whenever you need to. So it's a set of instructions the computer can run, on command. So the main function is the most important, or the starting function in C and C++. So all programs always start inside their main function. So it's important that you get this naming correct. You must have a function called main with a lowercase m, otherwise your program will not work. You must have at least one function with this name exactly. Now, there are a couple other things on this first line. The first part at the left is int. So this means integer, as I've written up here in this comment. Int or integer is a data type. Now, a data type in C and C++ is a very important concept. And in a lot of other programming languages, it's not quite as important, but C and C++ make this concept really, really explicit. You have to get your data types correct. So a data type is basically what type of information are you sending. So some examples could be an integer, which is just the same as in mathematics. An integer is 1, 2, 3. It's a whole number. You can also have data types, for example, a float. A float is basically a number with a decimal point. It's some non-whole number. So it might be like 105.3, for example. It could be 7.4. or it can have more than one decimal place. It could be 0.6357, whatever. It's a number with a decimal point. And then you can also have a data type like a character, which is a letter, or it could be a number as well, or it could be some other more complicated character. It's anything that makes up a piece of text. So even things like a space are a character. And there's another character at the end of this line which doesn't get printed, which is the new line character, or sometimes also carriage return character can be used to make a new line. So any component of text is a character. So those are the data types. Whenever you use a variable in C++, you need to know what data type it's going to be, and you need to say what data type it's going to be. So in this case, the int at the start of the function means this function returns an integer. So really quickly, what does return an integer mean? It means that when the function has finished doing everything that it is supposed to do, it's going to give you back some piece of information to say, I've finished and this was my result. So it's like in mathematics, if you were given a question to calculate, you had to calculate some number. The number you get at the end is the result. You would return the result to your teacher, for example, and say, this was my answer. So a function does something very similar. It returns some piece of data, in this case an integer, and says, this was my result, now I'm finished. So that's what this int at the start of the function name means. Next, inside these brackets, what is this part? Now again, I have written it up here, so you might have already started reading it. But firstly, the brackets are essential. You have to have brackets at the end of a function. So I will just quickly note that if you write something like this with nothing inside the brackets, this is also acceptable. You can have nothing inside these brackets, but even if there's nothing inside the brackets themselves have to be there. All right. So inside these brackets are two what are called arguments. Now, an argument is like an input. So back to your maths question analogy, if you were given a maths question and you had to calculate something, the inputs are the information you get told in the question. So like if you were trying to calculate the number of steps it takes to get from one position to another, your input might be the distance between the 2 points. And another input might be what is the length of one step. So you know the length of one step as an input, you know the total distance between 2 points, and then the question says calculate the number of steps. So the number of steps might be an integer and it might be your output, and then your two inputs could be the length of a step and the total distance between the 2 points. So in this case, these two arguments, these inputs are quite specific to the main function. So the main function always has these particular two inputs. Again, I will note you can have a main function with no inputs, and that is totally valid. And in fact, I will say that for a lot of your introduction to C++, especially first year subjects, you probably will be using this form a lot more often. You might never see main functions with inputs at all. You might only use main functions with no inputs. So that is perfectly valid, no inputs, but usually main functions do have inputs. And these particular two inputs, argc and argv, this stands for argument count and argument value. So the first one, argument count, is the number of inputs that you want to give. Again, this is specific to the main function. This is not the same for most functions. And I'll go through an example of that a bit later. So this is the number of arguments you want to give to the main function, and then this is the value of those arguments. So firstly, where do these arguments come from? So in this particular example, when the main function gets called, it is usually going to be called through the command line. So for especially first year subjects, you'll be doing a lot of command line input and output. So I will quickly just open up a command line and show you. Now this is going to be different because I'm running this on Windows operating system, and I believe all first year subjects are using Linux. I could be wrong about that, but definitely when I started programming, pretty much everything was Linux. In fact, I don't think I've used Windows ever, or at least I haven't needed to use Windows ever. It's all been on Linux. So this console will look a little bit different, and it does work a little bit different, but I'll quickly explain my point here. This isn't going to work. Actually, hang on, if I type anything, it will close the window. Okay, that's annoying. All right, if I type anything here, it's going to close this window. So I will not do it in the command line. I'll just do it here quickly. So normally when you run a program in Linux, you're going to type / the name of the program. So let's just say that it's called main. And then you can type something after it. So for example, I could type 10. I could type a word tree. I could type a number with a decimal points. So this would be an integer. This would be a string, which is a string is a list of characters, and this would be a float. So I can add as many arguments as I like after the name of the function, and these will all go in to here. So in this case, we would have an argument count of actually 4, not 3. So you might say 1, 2, 3 arguments, so this should be a 3. It's actually going to be a 4 because the name of the program always gets passed in as well. So when you go to argument count, you always get the name of the program first, and then you get anything else after. And these arguments are separated by spaces. So these spaces are not actually going to be given as input, they're just used to separate these arguments. Now, I can get rid of these spaces, and in this case we would have just the one argument plus the name of the function, which would make that a 2. And in the argument values, we would have 1 name of the function and 2 this. And you might say this doesn't make sense because it's got some numbers in it, it's got some letters in it, it's got a decimal point in it. What is this? This isn't an integer. It's not a float because it's got letters in it. You don't know what is this. Well, actually, it's a string. All of these characters, the 1, the 0, the t, the decimal point, all these characters are valid to make up a string. So that's why the type is a char pointer. Now, I will explain pointers in a little bit, but firstly, char in this case means any character. So all of these are valid characters, and the asterisks are the pointer component of that. So we want this second argument to be a char because that accepts literally anything. If we made this an integer, for example, it wouldn't work because this is not an integer. It's got a decimal point in it. And if we made this a float, it wouldn't work because it does have a decimal point in it, but it also has letters, and letters aren't valid for a float. So we want this to be a char so that it accepts literally anything. And then after we've accepted whatever our input was, we can then figure out what it actually is. So this is the type of command you'll be using in Linux to run your program. You'll type /. This / means go to the current folder that I am in and then run the thing called whatever this is. So this will be the name of your program. And then afterwards you add any arguments you need, or you could add no arguments as well. That also works if your program doesn't need any arguments. And I'll also say that you can add folder names here. So you can start with dot, which means current folder, and then say go into this folder and then run this program. So you can do that as well in a Linux command line to run the program. So once we've got our arguments, we then start the main function. So the first thing I've got in this particular function is I'm creating a variable. So a variable is very similar to a variable in mathematics, where your variable might be x and it's some unknown value that you have to calculate. In this case, a variable is something that is not unknown. You choose the value of it, but the value of it could be anything you like. So that's why it's variable. The value can change. It could be anything, but you do have to say specifically what it is. If you create a variable and don't say what it is, like this, I've created a variable, it's an integer, its name is unknown, but I have not said what it's equal to. This works, but it causes some annoying problems down the line. So I'll go through those problems in just a bit, but I'll leave that for now as this is valid, but you shouldn't do it. When you create a variable, you should say what it's going to be. There are some cases where you will have to do this, but you should be careful about doing this when it's not necessary, because it can cause you problems. So the variable is being created and it's getting a value of 10. Now, this equals is the assignment operator. So this equals means make the value of my variable 10. It's not asking the question, is my variable 10? It's making the statement, my variable is 10. If you want to ask the question, is my variable equal to 10, you need a double equals. This asks, is my variable 10? And that is different to saying my variable is 10. So in this case, we want to say our variable is 10, so we use one equals. That's called the assignment operator, and the double equals is called the equivalence operator. So double equals is a test, it's a question. One equals is a statement. All right, so next we're going to create another variable, and this is a pointer. So I said when we looked at these double asterisks, I'd explain pointers. I'm going to do that right now. So pointers, as I said at the start, are something specific to C that I don't think really exist in many other programming languages, or at least if they do, they're not as fiddly. They're not as annoying to use as they are in C and C++, because the big problem with C and C++, in my opinion, is it's a very old programming language. It's been around for a long, long time, and it's got a lot of relics from the past in it, which are very annoying to deal with nowadays, but they were the best thing that we had available when C and C++ were being developed. So really, they're not good to use, they're not fun to use, but we don't have any other choice, unfortunately. So a pointer, as I've written here, a pointer is called a pointer because it itself is not a value. Instead, it points at a value. So in this case, an integer pointer is not itself an integer, but it points at an integer. So what does that mean? That means that in our memory, which is usually RAM, random access memory, yeah, I'm sure everyone, well, maybe it's not right to assume, but I'm going to assume that most people understand what RAM is. It's random access memory. It's a card that you get when you buy a new computer. You plug it into a socket on the motherboard and it stores memory, right? So this is the address in that random access memory. This is a location where we will find an integer. So it itself is not an integer, it's a memory address. But if we go to that memory address, we will find an integer there. So here I'm creating a variable called pointer, and it's going to store the address of my variable. So this ampersand here, this means find the address of my variable. So ampersand and then some variable after it will give you the address of that variable. So we're going to find the address of my variable, and then we're going to store that in a variable called pointer. And since my variable is an integer, this is going to be a pointer to an integer. We can change this to something other than an integer, for example, a pointer to a float. And this sort of works in the sense that it won't tell you that anything's wrong. But when you try to read this value, the computer will think it's a float, and it's not actually a float, so it won't read the number correctly, and you will probably not get 10. You'll probably get some crazy answer that doesn't make any sense. So again, the type, which is this part in blue, the type is very important in C++, and you are going to need to get it right. If you don't, it will cause lots of problems for you. Sometimes, if you get the type wrong, the compiler will tell you it's wrong. Sometimes you'll get an error message that says this doesn't make sense. Sometimes it doesn't tell you. Sometimes you just have a problem in your program and you can't understand what the problem is, which is really annoying. So pay close attention to types and try to get them right the first time so that you don't have to go back and do it again or try to find a problem, because the longer your program gets, the harder it is to find problems. So we're getting the pointer to my variable. We're going to store it in this variable called pointer, and then we're going to print the value of my variable. So first of all, don't worry too much about this. This is a function that I have made called printer print. It's just going to print what's inside these brackets. So first, let's decompose what's inside the brackets. It's got a comma here, which means there are two inputs. The first input is this part in orange, which is a string. These double quotes mean that this is a string. And a string is just a list of characters. So each of these letters is a character, the space is a character, the double quotes, sorry, not the double quotes, the colon is a character. The second part of this input is false. So false is what's called a boolean. Now a boolean is a value that's either true or false. It's one of those two options, either true or false. So this input is just a constant false. I could put the name of a variable here. I could put the name of a variable like this in and say that my variable boo is a boolean. I can make it false, and this is exactly the same as what I had before. So instead of passing a variable as an input, I've just given it a constant false. And in fact, that's the same thing I've done with this string here. This string is just a constant, it's not a variable, it doesn't change, it's always the same string. On this second line, this is a variable. This is the variable we created up here. It's got the value 10. And we're going to pass that in as an input. So we're going to print that variable. And then we're going to have some blank, these are actually going to be blank lines, so that we have a space in our print output. Now, it doesn't matter about what the false and true mean because it's a function that I made myself, but I'll explain anyway. This false means don't make a new line at the end of this, and this true means do make a new line. So we can actually control whether when we print something we have a new line or not, because the new line is a character. And I will quickly show you in this other function. This is the new line character. \n means new line. This is what you use if you want to make a new line when you print something. The other option, you can also use /r, which is carriage return, which pretty much works the same. I haven't found an instance where they are different. They behave exactly the same as far as I can tell. So those are two ways to make a new line, but generally \n is the one that you'll be using. I believe that's the one that's used in most first year courses, if I remember correctly, unless they've changed it since I did them. But I believe \n is more common, although \r, as far as I can tell, it works exactly the same. So after we print the value of my variable, we then print the address of my variable. So this is just to show the difference between pointers and actual variables. So again, we're going to print this string. Now, this is actually called a string literal. So the word literal means I want you to print exactly what I've written here. Don't change any way. It's not a variable that could be changed. I want exactly this. It's literally this, a string literal. And then after that, again, we've got false, which just means don't put a new line at the end. And then we're going to print the variable pointer, and that's the end. Print a new line so that there's some blank space, and the print will be a little bit neater. Now, one important thing in here, well, no, I should rephrase that. Not one important thing. This is something that you probably don't need to worry about for now, but it is different and it might be standing out to you if I skip over it. This is called a typecast. So a typecast is when you change the type of a variable. Now, normally changing the type of variable is a terrible idea. It usually causes lots of problems, and most of the time you don't want to do it. But one of the times you can change the type is when it's a pointer. When you have a pointer to an integer, you can change that to a pointer to anything else. So this could be a pointer to a float, or a pointer to a character, or a pointer to anything else. This does work because pointers themselves are all the same, and the only thing you're doing is telling the computer that when you go to this memory address, what you find there will be an integer, or it will be a float, or it will be a character. But the actual pointer is just a memory address, and that doesn't change regardless of what it's pointing at. So you can change the type of a pointer without breaking anything, usually. If you do it, in a logical way, you can do it without breaking anything, as long as when you go to that address, you know what you're expecting to find. So these brackets here at the start, this is what does the typecast. This says take the variable pointer, change it to a void pointer, and then use it as an argument. So a void pointer just means it points at void. Void generally means nothing. So it's pointing at nothing. But in the context of pointers, when you point at nothing, point at void, it just means you're pointing at binary, some string of binary numbers. You don't know what type of data it is. So it's an unknown type, sort of. Again, don't worry about this. Don't worry about typecasting. Don't worry about typecasting to void. You will not need to do this for a while, definitely not in first year. I'm only doing it here because it makes writing this function a little bit more convenient. If I don't care what the pointer points at, it makes this function a little bit simpler, but it's not important. So finally, at the bottom we got return 0. This matches up with the int at the start. So this int at the start means that the function is going to return an integer, and we're now saying the integer we're returning is 0. I'll quickly go back to these comments at the top. If you read here, it says usually 0 means no error. Anything else is an error. So in the main function returns an integer. Usually 0 means everything went well, all good. If we return something else, like a 1, or a -1, or a -7, anything other than 0, generally that means some sort of error. And you can change which number you return to specify exactly what error you mean. So you could have 4 different possible errors, and they could be numbered 1, 2, 3, 4. So if you get a 1, you know error number 1 happened. If you get a 3, you know error number 3 happened. And you can do a little bit of debugging with that, but it's not the most efficient way to do debugging, because just getting a number out isn't generally enough to figure out what the problem is. But now I've gone through everything in this function, we're going to run it and look at the output. So over here we have my variable equals 10. This is the print from here. My variable is colon. My variable is 10. 10 is the value that we set here. So that worked. And then we've got a new line, as I said. This prints a new line. And then the next bit, the address of my variable is OX, and we get this as the output. So firstly, what does the OX mean? OX is a symbol you put at the start of a number to indicate that it is a hexadecimal number. So a hexadecimal number is a number which is in base 16, as opposed to a decimal number in base 10. Hexadecimal number is in base 16, so it starts at 0, and you go 0, 1, 2, 3, up to 9 as normal, as with decimal. But after 9, you can then have A, B, C, D, E, and F as your extra possible values. And then once you get up to F, the next number will be 10. So 10 in decimal means 10. In hexadecimal, it means 16. So this is a hexadecimal number, which is why it's got these letters FFC in it. This F is actually a 15. This C is a, see if I can count, it is a 12, I believe. A is 10. B is 11, C is 12, yep. So this C is a 12, this F is a 15. So this is the address of this 10. There is a 10 stored in memory, and this is where it is stored. It's stored at address 012FFC98. So this is the difference between a pointer and a variable. A variable is the actual value. A pointer is the address of that value. This is where in memory it's stored. So I will now go through my printer and function really quickly, because this is another really important concept for C and C++. It does exist in most programming languages. Alright, so the concept of a function is, actually first class. So classes in C++. So the first thing at the top, pragma once. This is something specific to, I believe, Visual Studio. It might work with some Linux C++ compilers, but I don't know if it works with all of them. What this means is, don't do what's in this file more than once. Only do the following once. That's what this means. Usually, I believe, with Linux, what you will have to do instead is hash if not defined, and then you'll create some value. So usually the value you use is the name of the file. So I'm going to call this printer_h, which is the name of the file. And then at the end, first define printer h and end if. Okay, that actually does work. So I can get rid of pragma once, and I can do it the other way. So this is the way that I believe works with all Linux compilers, or at least this is the way I was doing it in Linux. You start by saying if not defined. So you ask the question, does printer H exist? Now again, this printer H is the name of the file, and we want this to be unique for every file. So if this doesn't exist, we're going to define it. We're going to make it exist. And then we're going to do everything in the file, and this is the end to that if statement. So the point of this is to make sure that everything inside this file, everything in here, only happens once. We don't do this multiple times. And that's important because sometimes compilers get upset if you try to define things that already exist. They say you can't do that. So to make sure nothing breaks, we only want to run this once and not again. So inside here we've got, first word is the keyword class. Class means that we're creating a class, and the name of the class is going to be printer. So a class is a data type similar to data types of integer or character. It's kind of like this, except it's a custom one we're making ourselves. We're calling it a printer, and it's going to have some functions associated with it. These are functions that printers can run, and they are going to be public. So public means that anyone can access them, any part of the program can access them. Alternatively, they could be private, and in that case, only the printer itself can access its functions. But in this case, we want every part of the program to be able to access these functions, so they are public. Next, this keyword static means that you don't need to make a printer to use these functions. So what that means is down here, when I'm calling the function, I'm calling it on printer. I'm going into the printer class and calling the function print. But I haven't actually made a printer. So for example, I could do something like printer p equals new printer. So this line creates a new printer as a pointer. Okay, that's why there's a red line. The pointer was the problem. So this line would create a new printer, and then I could run some functions on that printer. But I actually don't need to do this because these are static. So static just means you don't need to actually make one of these classes to run the functions. They can run on their own without one of these classes being created. So they have some inputs. This one takes a string and a boolean as an input. This one is an integer, a boolean. This is a void pointer and a boolean. And they all have the same name. So this here is called overloading a function in C++. When you overload a function, you use the same name for multiple functions. So generally you might think if you use the same name, the compiler's or the computer's going to get confused. It doesn't know which function you mean because they've all got the same name. But you can overload a function name by having different arguments. So if the arguments are different, that is enough for the computer to work out which one you mean. It can say, oh, I was given a string and a boolean, so you must be talking about this particular version of the print function. Or if it was given an integer and a boolean, it knows it must be this version of the print function. So this is called overloading, and that will be covered in first year subjects, I believe. If not, it will be starter second year. Something like ADSA or ADDS definitely have overloading in there, but not too important for the moment. Again, I just made these functions to make printing a little bit neater on this page. So after we've defined these functions, we then need to tell the computer how they actually work. So this is the sorry, this is the definition of the function, and then this is the actual function itself. These are the instructions that make up the function. So at the top we do some includes, similar to them in the main.cpp. Includes, this means find these other files, and we're going to use parts of these other files in this file. So we need to go look up these files and find them. So these are the same three versions of the printer function, with the string boolean, int boolean, void pointer, and boolean inputs. And they all do a very similar thing. They just run this function called standard cout and give it an input. And then if the boolean is true, we're going to add a new line. So first of all, what does this mean? This is a C++ specific way to print a variable. You type standard cout. This is part of the IOStream, input-output stream library, so you have to include the input-output stream library in order to get access to standard cout. And then if you use these two left carets, this is the output operator. And you can put a variable or a number or anything. Yeah, variable, a number, a string. I think you can put pretty much anything as long as you didn't create it. So I can't put a printer here because I created a printer. So a printer won't work here, but pretty much anything else will work. And it just prints whatever's here. So you can print the string like that, and then you print this new line character. So quickly, an if statement. What is an if statement? An if statement is basically a question. You ask a question: if this thing is true, do this. So if new line is true, and it's a boolean, so it can either be true or false. If it is true, we're going to do this. If it's not true, we're going to do nothing. You can add an else here. If you add an else, you can say, if this thing is true, do this part. If it's not true, so else, do this part. In this case, if it's not true, we want to do nothing, so we don't need to bother with the else part of that if statement. And this is similar for the int and for the void pointer. They're all the same, more or less. So I think that is enough for now. I've gone through a lot of the basic concepts in C++ and C. I will quickly say most of them will be the same for C and C++. The couple of things that are different is C++ does not have, C++ has classes, C does not. So you can't do classes in C. And this standard cout way of printing doesn't work in C, only works in C++. If you are using just C, not C++, most of the libraries have different names. Most of them have a .h at the end. So like string.h is the C library for all things to do with strings. String is the C++ library for all things to do with strings. But mostly this is the same between a C and C++. There aren't too many differences. Yep, I think that's enough for now. I've explained all the basics. I went through pointers in particular. So quickly refresh on pointers. They are memory addresses. They're locations in memory. And you can store anything you want at a location in memory. So you need to keep track of what's actually stored there. You need to know what's stored there and make sure you get the type correct. So again, these types, in this case an integer pointer, you need to get them correct, otherwise things will not work. Right, so thank you for going all the way through to the end of this video. I think that is enough for today. If you have any questions or any things that you need further clarification on, please let me know. I'm happy to make another video explaining something in more detail. Happy to make another video on a different concept entirely. Let me know. Right, thank you.